Okay, the title's a hook. I mean, it's the end of the day, everybody's tired. I don't know about you, who else was up till 3:30 in the morning releasing software last night? Yeah, I was. Because Intel gave us patches last Tuesday and nobody releases on Friday. So I knew I was gonna be here, but fortunately the crew stayed up. So yeah, electric cars are the future. I actually drove a Tesla for 3 years and I went back to Toyota Land Cruisers, but that's a different story. It's absolutely true. My wife will tell you that I own way too many Land Cruisers. But yeah, electric cars, they're a lot of fun, they're cleaner. I enjoyed the heck out of the one we had. I actually had a Tesla Model S. And containers are the future too, right? We're here at KubeCon. That's where we are, right? Is everybody awake, or should we just go home? But it's going to take a while before containers become the dominant thing in networking or the dominant thing in compute. Containers projected to be in 2020 like a $2.7 billion market, while the rest of the computer market is 170 billion. So this is like 60 to 1 outspend. Those will converge over time. The question is sort of how long. In the meantime, I hope everybody in the room has seen this, if you're connected with FIDO. This is FIDO's marketing slide. So over on the right is cloud native. That's why we're here. And the other 2/3 of the slide are things we can do yesterday. The one on the far left is discrete appliances, sort of bare metal, and the one in the middle is VNFs. So, we've got a product out that we can talk about or not. It's got VPP as a core in it. And we can talk about a couple of conventional deployments we have already today. So the first one, all 3 branches of the US military have a cyber school now, where they teach young people typically how to offensively and defensively deal with computer security in the big bad world of the internet. So the one we're involved with has about 8,000 current users and a private cloud infrastructure and a campus. And so, they connect these, this cloud together with 100 gig interfaces, and then they have a campus that's also routed with 100 gig interfaces. And they do the typical NAT and port forwards and scanning everything, including, wanting antivirus out the side. And we started talking to them because they'd been involved with pfSense. This is the open source project that I run and that we were releasing software on to last night. About 1 million active users. We just passed 1 million that we can see in a short period of time. But they weren't getting the performance they wanted, and they wanted to be able to deal with orchestration via an API. They eventually want to be able to spend up about 10K routers inside this infrastructure because they're teaching people. It's a lab environment. If you graduate from the school, you have access for the rest of the time while you're still in a military branch to that environment to get continued training. So the solution, everybody's got an architecture slide today. We put ours up. This looks a lot like what you saw from Sweetcomb or some other people today. We use instead of this repo, we use a thing called Clixon, which is also open source, actively developed. We took a long look at this repo and decided to go this way instead. We ship with a RESTconf interface because everybody under the age of 30 wants to only deal with HTTPS. I see advantages to netconf too. Two-phase commits are great. You get a commit after every transaction in RESTconf, but it's still easier for people with curl to program against or implement simple scripts and this kind of thing. And the rest of it you've seen before, DBDK, free range routing or Quagga, a router plugin, strong swan, that kind of thing. So the engineering challenge, and I should just let Mason come up in the room and explain the slide instead of me. But by the time you send the shortest possible Ethernet packet, you've used up 84 bytes of space and time. 12 bytes of that is an interframe gap that you don't see on every packet. It's not occupied, it's vacuum, it's empty space on the wire, but it's going to be there, and that's how you get to 84. 84 bytes is 672 bits. The math gets pretty easy after this. You have 67 nanoseconds to forward a frame, to do everything you're going to do at this max rate. And as the speeds go up in the NICs, if you're going to maintain that line rate, you just keep dividing by the speed of the NIC divided by 10 gigs. So you have, at the end of the day, about 134 clock cycles or 134 instructions to deal with the packet you have in your hand. Memory is not much farther away, right? Memory is about 70 nanoseconds, 72 nanoseconds, depending on where you are. You've got less time that gets the packet from memory into the CPU to actually start doing work. And again, as you start going to 40 gig or 100 gig or beyond, your time just keeps slicing down. So this used to be the domain of ASICs. You had to have an ASIC, everyone would tell you. Enter VPP and you don't necessarily need the ASIC anymore. You don't need the TCAMs, they showed up in the caches for free, right? So these are our numbers. I can't afford quite the same CPUs that Masick can in his lab. I used to do these with an i7 that's overclocked and water cooled because it's really fun to be able to run 4 gigahertz and forwards and packets. But these are all done with a 2.1 or 2.05 gigahertz Xeons, Skylake Xeon 6130 or something like that. And you got to watch what the marketing people do because they've added forward and back for bidirectional. So you'll occasionally see things like, how do you do 100 gig on 100 gig, over 100 gig on 100 gig NIC? And that's where that came from. They've added the forward and reverse directions. Across the top, this is single core used. So iMix, we can forward at about 7.5 million packets a second, which translates to about 22 gigabits. And then you can scale out across the number of cores. We do actually get around 100 gig unidirectional, around 512 bytes per packet. So the net is, you can do 100 gig with boxes that you can buy off the shelf. Nothing special other than the software. For IPsec, you have to do a little more work on the packet. Encryption costs time and a string. But at the end of the day, you can still get about 7.5 million packets a second. Well, no, it's about a third of that. 2 million packets a second per core on a bog standard Intel Skylake Xeon. A $600 CPU, not a $6,000 CPU. Yeah. What? Yeah, it's IP routing, it's L3 forwarding. We don't really have a lot of use case for what we do for L2, so. And IPsec gets me up in the morning. So, with and without Quick Assist, you get a little more scalability. You can save a few cores if you start scaling out. But find a Quick Assist in the cloud, right? No, and somebody's built out the slide wrong. So before FIDO, we were doing this PSense thing, and we see about 300. By the time you get all the packet processing overhead in, so just simple L3 forwarding, you can get more than 300 million packets a second. But by the time you add in some NAT and some packet filtering, this is about what we were getting and about what the cyber school was getting on these Skylake Xeons, about 300 million packets a second. That's not great. And then, they were, dealing with having to configure via GUI, not via an API, and this kind of thing. And then after, we brought Tensor to them via FIDO, getting 100 gig was easy, and they were really happy about that. And they liked the API, and they liked the performance, and they liked the fact that they could treat, all 12 of their routers as sort of one thing. So at the end of the day, for less than $25,000 and all in, they can get a 100 gig router. And when you have 12 of those, you can do the math. They've saved a bunch of money, and the government likes saving money. The next User scenario is we got approached by somebody else who's in the InfoSec world, talks to a lot of Fortune 500 clients and some DoD clients. They do a security monitoring service or security monitoring software. And then, they want to automate both detection and response to perceived threats. And they don't like agents. A lot of the existing architectures out there put an agent on every endpoint, and then you have to manage all the agents. So these guys also approached us because of pfSense, and we said, we'd rather do this with Tensor, and we'll get to that in a second. So the deployment diagram here is, you've got, your VPC full of stuff, web servers, and you put a router in, and then there's a GRE tunnel that goes over to their software, and then they do the monitoring. So, before VPP came along, you had to basically copy the packets, out of the kernel into some kind of transfer across user space, send them back to the kernel, get them run across the network, and then do whatever you're going to do on the other side. Or you end up deploying one of these Gigamon agent systems, and nobody liked paying for that. Afterwards, sort of, we showed them the documentation, gave them the API, and they were like, "Yeah, this is easy." They plugged it all together, and the very next thing was, it's overrun our sensors, right? It's too fast, or it's faster than we know how to deal with. So, could you figure out a way to basically let us scale this out and do multiple, GRE tunnels? And we're still working on that, but because they wanted to do Azure next. This was all on AWS. Azure uses GRE for their internal transport. You can't transmit GRE over Azure. So we had to find a different way, and VXLAN is what got picked. So, at the end of the day, they got what they wanted, and they actually got some more sensors to their customer base. So they were very happy, and I think they're actually quoting off, 25 gigabit scanning now. So, VPP is an open source project, and I'm a vendor, and there are other vendors in the room. Why does a customer need an open source vendor? Why can't you just take the stuff and compile it yourself? So there's sort of, a couple big reasons. One is most customers tend to want to buy products. They want something that's supported, that's tested, that comes with documentation, and the rest of it. And the other is they want somebody to call when it all goes wrong. Cisco has a business because of this. Intel, in some respects, has a business because of this, and most service providers have a business because of exactly this. So, sort of first, I'm kind of proud of and worried about the slide at the same time. This is commits to the VPP code base. And number one, of course, is Cisco. And number two is independent, but if you go actually out and look at the addresses used in independent, there are a lot of Gmail and Yahoo addresses used by Cisco and other people like Pantheon, who are contractors for Cisco. So for the most part, this is also Cisco. And number three is Intel, and number four is little tiny Netgate with less than 70 employees. And you can sort of see the rest of the list. I've expressed an internal goal to the people at Netgate to capture and exceed Intel here. I have no aspirations about getting bigger than Cisco here, but I think we can probably catch Intel. At the same time, I find this worrying because there should be more people on this slide. If I can do it, almost anybody else can do it, right? And there should be more people participating in this than what we have. Number two is, you actually have to turn what exists into a product. People on open source projects love changing things. Neil just changed IPsec. Is anybody aware? Broke all of the DPDK drivers. It was great. we fixed it. I mean, and I think actually he fixed that one, but we said, hey, you know, the test suite just shattered. You might want to, and like every other release breaks NAT with IPsec. I don't know why. So this is one of the things we actually went out and, you know, wrote our own test suite for this stuff, so we would know when things were in shape, when we could release or not. But we run it every night as well, just like, you know, CSIT runs every night. Our test suite is written to drive via both our CLI and the RESTconf interface, but the overall idea is, yes, we should certainly push those up. And we took the router plugin and made it work, and then made it work well. That said, it's not a long-term strategy for us. There's a much better strategy, you know, place for using punt and the host stack, and getting rid of the router plugin. And I know other people in here use the router plugin, so, you know, maybe there's a path forward there for everybody. And then we've also integrated with FRR and Strong Swan and the rest of it. And the rest of this is, you know, sort of, you know, like I said, I was up till 3:30, making releases and the rest of what goes into actually selling a software product to people. You don't think of that much in the open source world, but, you know, there are vendors and they employ programmers, and that's where a lot of the work comes from. So, you know, in summary, you know, the success of FIDO depends on how many people use it, right? And containers are, really, I'm fully behind containers, but in the now, they're less than 2% of the market. So near term, you know, bare metals and VM deployments are what we're going to see. And customers tend to be less concerned with the packaging around the product than they are with it's ready for them to use, and there's somebody there to hold their hand if it doesn't work right. And we can take that idea into the Kubernetes world as well, and that's all I have. Any questions?